In this video, we're going to talk about radicals. Radicals are going to help you learn how to think about factoring trinomials a little more appropriately. A radical sign looks like this, where a square root has an understood index of 2 that we don't write in the radical. If we were to write it there, it would look like that. But if it's a square root, we don't write it there. For all other roots, we place the number at the top left of the radical sign. It's important to remember that radicals undo exponents. Let's take a look at 3 examples just to get you kind of up to speed on how to think about radicals and simplifying them. We have a cube root of 4 to the third. Notice that the index, the number to the top left, matches the exponent inside. Because of that, and because radicals undo exponents, we can write that as 4. Let's take a look at the next example, 25. 25 is a perfect square, so we know we could write this as the square root of 5 squared. Notice that again, we don't have that square root here in the index, the 2, but it's understood to be there. Because of that, we can write this as 5 because the exponent and the index undo each other. Let's take a look at root 6. Root 6 is the same as root 2 times 3. Notice that there is no perfect square here. This one cannot be simplified, and we would just write it as root 6. Another way to evaluate this is by saying that it's a decimal equivalent to something. In fact, 2.449, etc., etc., etc. What this means is if you multiply this repeating decimal number to itself, you will get about 6 back, but it's not an exact number or a perfect square. Simplifying radicals mean we need to break down the numbers using factoring, just like I did right here with 2 and 3 making 6. Eliminate the matching exponent and index where possible. This means that if you have an exponent that is greater or equal to the index, you can usually pull that factor outside the root and let it sit outside of it instead of inside the root. When you're all done, you'll multiply the numbers that match in the radical signs back together if there's no more simplification possible. In example 1, we have 343 under a square root. Remember, there's a 2 out front here. First of all, we're going to factor the 343. Working through my primes, I recognize that 7 is a factor. If I divide 343 by 7, 7 goes into 3 0 times, 7 goes into 34 4 times. 4 times 7 is 28. And I'm left with 6. 6 and 3 are my remainder when I drop this down. 7 and 9 make 63, and I have a 0 remainder. So I know that my other number here is 49. This happens to be a perfect square of 7 and 7. I can rewrite my radical with these numbers here, the 7s, written as an exponent, 7 to the 3rd. Notice that my index is 2 and my exponent is 3. My exponent is larger than the index. That means I can take 1 7 out and leave 1 in because that's my remainder. I check to see how many times my index will divide into my exponent and what my remainder is. 3 divided by 2 equals 1 with remainder 1. So I have 1 outside and 1 inside. Let's take a look at example 2. We have the cubed root of 144. 144 factors to 12 and 12. We could keep factoring this further, and we probably should because this would be a perfect square. 144 is a perfect square, but not a perfect cube. But since these are not primes, we can keep going. We know that 3 times 4 makes 12. And we also know that 4 is 2 times 2. So my prime factors are 3 and 3 and 4 2's. So let's rewrite the radical with those exponents inside. This is equivalent to the cubed root of 3 to the 2nd times 2 to the 4th. From here, I can look at my index and ask myself how many times will that 3 go into 2. It won't go into 2 any time, so we have to leave that inside the radical. However, 3 will go into 4 one time with 1 remainder. So the 2 comes out to the 1 power, and the 2 stays in to the 1 power because that's my remainder. So my final answer is actually 2 times the cubed root, put my 3 there, of 3 squared times 2. Now if you want to make this look really pretty, if you're into making math look really pretty, you can do 2 times the cube root of 3 times 3 is 9 times 2 is 18.